has done his exam. We know it works. We are using it. So this is definitely part of it. So then we have logic. Logic, for example, we have decision trees and all its derivatives, and we have things like fuzzy logic. Again, I have been around in the past 2-3 months, and I hear again and again in some conferences which are dominated by colleagues that have put all their eggs in the basket of deep learning. Dangerous thing to do, especially for young engineers. And I hear, yeah, so the logic approach is gone, so symbolic approach is gone. I don't think so. I want to keep to those stuff still. I see they are working in my lab. Why should I abandon them? Why should I abandon something that is working? So there are things that are in the middle, like reinforcement learning, that have no connection to anything else, but they have been specifically for engineering design crucial. Do you think we can come up with a Mars rover navigation system without relying on technologies like reinforcement learning? Not going to happen. How much training can you do in Nevada? How similar is that to Mars? I know, it's not red. So how can you be sure that when you deploy it in a completely unknown environment, it does fine? It has to learn from scratch. It has to learn from interaction. Not possible with neural networks. Not shallow, not deep, not average depth, whatever. You need techniques like reinforcement learning. Robotics without reinforcement learning, unimaginable. Not going to happen, because you need the interaction. And networks are static. After they learn, they are static. You just use them. They cannot be adjusted anymore. Not the regular way, unless we come up with some tricks. So then we have classifiers. And we have clustering. Of course, again, as I mentioned, we have k-means. We have FCM. We have support vector machine, and we have many others. These are just, please be careful that these are just examples. We have many other clustering and classification techniques that we may not mention. But I think historically and practically, we benefit a lot when we talk about this tree. But there are many others that people are using. So encoding, method like PCA, very old, and method like TSNE, T-S-N-E, which is very young. So how do I use those techniques for dimensionality reduction or for visualization? Visualization is very important. Now, retrospectively, we are rediscovering the power of visualization, because if that black box contains 1 billion numbers, okay, who can understand that? Nobody. Do you think people use it if they cannot understand it? You will make the experience when you go out in the real world as an engineer that your customers want to understand the product. They want to know how it works. Because they don't want to be just stupid users. They want to know what is behind it. What does it mean when it says this? So important to have visualization techniques like TSNE. We have techniques that are on the border and go a little bit out. Meta-heuristics. Like genetic algorithms. Like, I bring it a little bit out, like swarm intelligence, ant colonies, things like that. Some colleagues, that's the reason that I push this to a little bit out of the AI, because some colleagues may disagree with me and say, no, they are not AI techniques, they are optimization techniques. Well, that's my argument. You cannot have artificial intelligence if you cannot do optimization. Can't happen. You have to optimize the topology of the network, you have to optimize the weights, you have to optimize the batch processing. You have to optimize everything. How can you learn without